Hello students, welcome to the next subtopic of Semiconductors chapter, and in this subtopic we are going to learn how this PN junction diode can be used for rectification purpose, how it can be used in a rectifier circuit. So let us now say first what is called as rectification. So what is rectification? Rectification is a noun form, so we can say it is a process. Rectification is the process in which AC voltage it is converted into DC voltage. Okay, so the process in which the conversion of AC voltage into DC voltage is there. We can say this process is called as rectification. And what is called as a rectifier? Rectifier is an electrical circuit. So an electrical circuit which rectifies AC voltage is called rectifier. Okay, rectifies AC voltage means AC voltage is getting converted into DC voltage. That is called as rectifies AC voltage. So there are two types of rectifier circuit: half wave rectifier and full wave rectifier. So we are going to learn both half wave as well as full wave rectifier. First, let us see what is the meaning of rectification. What is known as AC and DC voltages. Or if suppose I draw some current waveforms to you, and I ask you whether it is an AC voltage or DC voltage, you have to answer me that which one is AC and DC voltage. Okay, so this is the current axis and the another is the time axis. So for example, I am drawing the wave like this. This is the wave number one. The wave number two, it is like this. The wave number three is like this. And the wave number four is like this. So which of the following is AC and which of the following is DC? This we have to note. Okay. Now, what is AC? AC means whenever we can say a reversal of current is there. Reversal of current is present. There I can say it is an alternating current. While DC you can say DC is the direct current in which reversal of current is not it is not present. The current will move only in one direction. So what do you mean by DC? DC means current moves only in one direction. Current flows only in one direction. If suppose the current is flowing in the opposite direction periodically, I can say it is an alternating current. Okay, so here I can say this is the first quadrant or this is the fourth quadrant. So whenever there is a change in the quadrant in the current, so whenever the current changes the quadrant from first to any other quadrant, I can say there is a reversal of current taking place and it is called as alternating current. So this is the alternating current. While in this case the current it is there in the first quadrant only, so I can say this is the direct current. Again in this case the current it is fluctuating, okay, but the current it is there in the first quadrant only, so again I can say it is the direct current. But what type of direct current means pulsating, so this is called as pulsating DC. Okay, but it is not an AC because the reversal of current is not there. But if you look at the waveform number 4, the a part of the waveform it is there on the fourth quadrant. I can say this is nothing but this is nothing but alternating current. Okay, so this is nothing but alternating current. So I hope you understood the difference between the alternating current and direct current. So we are going to learn rectification, the rectifier circuit in this subtopic, and it is nothing but the conversion of alternating current. So we'll see how this waveform number one it is getting converted into waveform number two. Okay, in the process of rectification, right? So as the discussion says that the rectification circuit in our syllabus it is classified into two categories. The first one is the half wave rectifier, the another is the full wave rectifier. So we are going to learn about half wave rectifier first. half wave rectifier. So remember that in half wave rectifier there will be only one diode. So one diode will be present in the half wave rectifier, while in the case of full wave rectifier there will be two diodes. So PN junction diode, if suppose I draw the electronic symbol of PN junction diode is like this. So this side is positive terminal and this side is negative terminal. Okay. So when I can say it is the forward bias, whenever the positive is connected to positive terminal of battery and the negative is connected to the negative terminal of battery, I can say this is the forward bias condition of PN junction diode. While if suppose I consider this is the diode, okay, this is the P type, this is the N region. Whenever the positive is connected to negative terminal of battery and negative is connected to the positive terminal of battery, I can say this is the reverse bias condition. So in the case of reverse bias condition, the diode it is off. Diode it is off, that means it can be considered as an open circuit. So this we have already learned in the 11th standard. And in this case, the diode is going to be on, and that means it can be represented by a short circuit. Okay. That means it is the closed switch. Diode is on, that means it is the closed switch. And diode it is a off, that means open circuit, that means it is an open switch. It is an open switch. Okay. So this is the revision of the PN junction diode. Now we'll see how this PN junction diode is connected to a half wave rectifier. So this is the circuit diagram of a half wave rectifier. You can say the input is the standard AC voltage which is supply in the in India. The standard AC voltage is 230 volts 50 hertz. So 230 volts 50 hertz AC supply. Remember that whenever you have to write AC, you have to write small and small c, and whenever you want to write DC, you have to write capital D and capital C. So this is 230 volts 50 hertz AC supply. So this is the transformer. So this is the transformer. So transformer, what it does, transformer it isolates the primary and secondary coils. So there is no direct wire connection between these two, so that it can eliminate the possibility of electric shock, right? So here the number of turns is more, here the number of turns is less. I can say this is the step down transformer. Step down transformer, that means voltage will decrease while the current will increase. Okay. So in order to avoid the confusion, I can say this is 1:1 transformer. 1:1 transformer means whatever is the input, the same is going to be the output. Whatever is the input, the same is going to be the output. Okay. So this is called as 1:1 transformer. 1:1 transformer. Now, whatever is the changes on the primary circuits, whatever the changes in the primary circuit, the same changes will be reflected in the secondary circuit. So this is the primary circuit and this is the secondary circuit. This is also called as primary coil and this is also called as secondary coil. Okay. So I can say the rectifier circuit, it will be moving like this, the current will be moving like this. So this will be first half cycle, and in the another cycle the current it will be moving in the opposite direction because it is an alternating current, right? And we have to convert that into a direct current. So this is the first cycle, and after some time the current it will move in this opposite direction like this. Again the current will move in this direction, again the current will move in this direction like this. Like this the current will be moving, like this the current will be moving in the primary circuit. Okay, from here to here, then here to here again. So this is called as alternating current. So whatever is the current changes in the primary circuit, because there is a transformer, so there will be the same changes in the secondary circuit. So if suppose this is positive, so in this case this is positive, this is negative, this is negative. After after that particular cycle, if suppose this value is negative and this value is positive, I can say this is negative and this is positive now. Okay. So this is the function of the transformer. This is the function of the transformer. Now this is V in. V in is the input voltage. So whatever we are getting, we are inputting the voltage, the same voltage we are getting over here. Then I can say this is the diode. See how the diode is connected. This is the positive terminal of a diode. This is the negative terminal of a diode. Okay. And this is the load resistance. Load resistance means the resistance of any electronic device which is connected in the rectification purpose. For example, um, we have the power supply AC mains power supply we have, and there are some components which work on DC supply. For example, TV, mobile phone charger, these all work with the in the DC supply. So this is the resistance of the mobile phone, or I can say this is the resistance of the TV. This is called as load resistance. That means the resistance of the output side. Okay, resistance of the output side. Now we'll consider the half wave rectifier in two different, say, positive half cycle and negative half cycle. So you have to remember the circuit diagram. So half wave rectifier in the positive half cycle. So I'm drawing the circuit diagram like this. This is the input side, right? This is the input side. In the positive half cycle, suppose the current it is moving in this direction. If the current is moving in this direction, so current always moves from positive to negative. So this is what positive and this is what negative, such that the current is flowing from positive to negative in the downward direction. So this is 230 volts, 50 hertz AC supply. So this is what a transformer, and now the diode it is connected like this. This is the diode which is connected, and after that there is a load resistance R. This is the load resistance R. Now during the positive half cycle, I am considering the current is flowing in this direction from positive to negative in the downward direction. So again, since it is the transformer, the same polarity it will be induced. This is going to be the positive. This will be the negative. So if this is positive, this is negative. This is P type of semiconductor. This is the N type of semiconductor. Positive is connected to positive terminal. Negative is connected to the negative terminal. That means I can say this is the forward bias. So this diode is forward bias. So in the case of forward bias, this diode is going to be on. This diode will be on. So if the diode is on, it can be replaced by short circuit. It can be replaced by short circuit. So short circuit means I can replace this diode uh, just like this. So this is what the short circuit is. That means nothing is there. So the current will be flowing from positive to negative like this. Current will be flowing from positive to negative like this. So in which direction the current is flowing? Through RL. In the downward direction the current is flowing through RL. This is all about the positive half cycle. If suppose I draw a waveform, if suppose I draw a waveform, this is time and this is the input. This is the wave, right? This is the positive half cycle, this is the negative half cycle, this is the positive half cycle, this is the negative half cycle, this is the positive half cycle. Okay. So output, what we are getting output. So in the positive half cycle, we will be getting the output same as that of the input. So whatever is the input, the same output we are going to get in the positive half cycle. So whatever is the input, the same output we are going to get in the positive half cycle. In the positive half cycle, we will be getting same the same output as that of the input. Okay. So this is all about the positive half cycle. Let us now move to the negative half cycle. Okay, you can pause the video, you can note the things down. So half wave rectifier in the negative half cycle. Again, I will be drawing the circuit for you. So this is what 230 volts, 230 volts, 50 hertz AC supply, a standard supply for India. Then there's a transformer. So this is a transformer, and there will be primary and secondary windings like this. Now I am considering the negative half cycle. Negative half cycle means the current is flowing in like this. In this direction, the current is flowing. So the current is flowing from positive to negative always. So I can consider this side is positive, this side is negative. So that the current is flowing in this direction from positive to negative. So this side is positive, I can say this side is considered to be positive, this side is negative, I can say this side is considered to be negative. But how the diode is connected? The diode is connected like this. Always the diode is connected like this. So this is the positive terminal and this is the negative terminal of PN junction diode. Now positive is connected to negative terminal and negative is connected to positive terminal. I can see this is the reverse bias condition. So in the case of reverse bias condition, the diode it is what off. Diode is off. So if the diode it is off, I can replace the diode by open circuit. So this is what an open circuit. Okay. So I can remove this diode and I can replace it with an open circuit like this. And after that there is a load resistance. So this is the load resistance R. Now see the current will flow from positive, but this is an open circuit, so no current flows here. So this is what no current flows. No current flows. So what we concluded in the negative half cycle, the current flowing to the diode is zero. The current flowing to the half wave rectifier circuit is zero. So suppose this is the input side, this is the input. Now this is the negative cycle, negative cycle. I can say output, this is input, and I can say this is the output waveform. So output waveform it is zero for the negative half cycle. Output waveform it is zero for the negative half cycle. So it is zero for the negative half cycle, zero for the negative half cycle. While for the positive half cycle, we have already learned what we have learned that the output will follow the input in the case of positive half cycle. So this is the complete waveform of the half wave rectifier. Why it is called as half wave rectifier? Because for a complete input wave, so this is the complete input, this is the complete input wave. The output we are getting is only the half part of the input. So only the positive half cycle we are getting, while the negative half cycle is zero. So that's why this is called as half wave rectifier. That's why this is called as half wave rectifier. Okay. So I hope you understood the half wave rectifier circuit working. You can again watch the videos if you want. Okay, you have to note the things down. Okay. So what is the output waveform of half wave rectifier? This is the output waveform of the half wave rectifier. So in this case, this is what the positive half cycle. In this case, this is the negative half cycle. Again, the positive half cycle, this is the negative half cycle. So this is what in the case you can say this is diode is on, and in this case the diode is off. In this case the diode is on. That means it is the forward bias case, and in this case the diode is off. That means it is the reverse bias case. Okay. So the frequency, what is to be noted is frequency of output voltage is equal to the frequency of input voltage. Frequency of input voltage. Okay, so the frequency part will remain constant. Frequency part will not change. Okay, don't think that let's suppose the input it is of 50 hertz, then the output is going to be of 25 hertz because it is an half wave rectifier. But this is not happening. The frequency part will remain same. The input is of 50 hertz, the output will be of 50 hertz in the case of half wave rectifier. Okay, so you have to remember these things. Now, this is not a pure DC. What I can say, this since the quadrant is not changing, I can say this is the pulsating DC. So this is the pulsating DC. So remember that always from rectifier output will be pulsating DC. Rectifier output will be pulsating DC. Always you remember like this. Rectifier output will be pulsating DC. Okay. So pulsating DC can be converted to pure DC by moving to the this filter circuit and regulator circuit. It can be made a straight line. You can pause the video, you can write the things down. Okay, so this is the all about full wave half wave rectifier. The next topic that we are going to learn is the full wave rectifier. Thank you so much, all of you, for paying attention. Keep learning, be healthy.